What is science? Well, that's a good start to a science course. Let's take a look at some key components of what makes up science. First of all, what we're looking at here is something recently discovered or recently taken. It's a picture here on the right, and this picture on the right is a picture into deep space. Now, what we have here on the left is the James Webb Space Telescope, and it's orbiting the Earth, and it's basically complementing and extending the discoveries of the Hubble Space Telescope. And the Hubble telescope took some amazing pictures for us, but what it does is it has longer wavelengths that enable the Webb to look much closer to the beginning of time and to hunt for unobserved formation of the first galaxies. Crazy. We can look into dust clouds where stars and planetary systems are forming. Very amazing stuff. And this just recently became available to us. It's so neat to look at. It almost looks like fake. I mean, it's so incredible. So when we think of science, you should think of curiosity, right? So curiosity, we've all been curious before, and these are some examples right here that people are thinking about how to solve problems. But maybe you've thought of ways you've been curious about the world. Maybe not what's inside of a baseball, or if it would taste better to put more chocolate or less chocolate in your milk. But you've probably done something like that. Maybe you thought of something like you were swimming in a pond and you thought it'd be cool to dive as deep as you can and touch the bottom and see what's in the bottom. These are all examples of curiosity and solving a problem or answering a question. And curiosity is a huge part of what we know to be science. There are a few things we should look at when we look at observations when we start thinking about curiosity. The first one is a qualitative, and the second one is quantitative. Now, a qualitative is going to describe something using adjectives. For example, talking about the color of something, whereas quantitative observations deal with a number. So you could say that something about, I have 6 shirts, so that'd be quantitative. Or I really enjoy wearing my red shirt, red being qualitative. So sometimes, though, when we think about those things and think about the difference between quantitative and qualitative, we start getting into things like the question can't be answered with observations or with measurements. We have to use other kinds of evidence to figure that out. And science and technology go hand in hand. That's the great thing. If you enjoy technology, if you enjoy using your computer, or if you enjoy possibly, playing some sort of game that on your phone that involve technology, science and technology go hand in hand. And science is a system of knowledge and methods to find more knowledge, and we want to get that knowledge expanded. We want to discover more things. Whereas technology is the use of knowledge to solve practical problems that are right in front of us. So this is like learning things just to expand learning and knowing things, where technology is, we have a problem we want solved. So here are some things right here. It says the telephone was invented in 1876. And look what's going on here. Over a few years, things have changed quite a bit. And these are all relics for sure, including this one right here is a relic, knowing what kind of phones we have now. The branches of science. Take a look at this here. We're talking about science. Science is divided up into 3 main branches. We have physical, which we'll focus on to this year. ICP is C, chemistry, and P, physics. You may have taken earth space First space deals with geology. Geology is the study of what we have here on Earth, minerals, rocks, volcanoes, whereas astronomy focuses on what's going on outside of Earth. Life science is biology, and you can see botany is the study of plants, zoology is the study of animals, ecology is the study of biotic and abiotic factors, genetics looks at how we are made up and our traits are determined by our genes. But what about the one we're focusing on right now, which is chemistry? Well, that's the study of matter, mostly in relationship of how it's made up. And then physics is focusing mostly on movement, motion, and that matter that we just talked about. So this is a close-up of it if you need help seeing it. As you can see, these kayakers are in motion. Physics is a huge part of motion is a huge part of physics. Chemistry, we talk about the composition of things. Again, geology, rocks, minerals, weather, the oceans. Astronomy is looking at things like the Jack Webb telescope. And then, like I said before, biology. You probably know all about biology after taking biology as a freshman. There's a huge, lots of branches there. So, as I said, we'll focus more on chemistry and physics. Right now, we're looking at the structure of composition, the structure in relationship to properties and the reactions of matter. And again, physics is a lot about the interactions and focusing on different forces in our universe, and especially motion. And again, geology, how the Earth become what we see now. How do we classify things here on Earth? And then outside Earth, beyond Earth, what's going on in the universe, which is exciting stuff. Biology can include physics inside of it, and definitely chemistry. The only way to understand DNA, for example, is to understand chemistry, really. And that's the cool part about chemistry. It's considered the central science. So physics and chemistry both are intertwined in all of the sciences. And like I said, lots of overlap here. Much of biology involves changing that part of chemistry, looking at different things inside of chemistry and how those bonds and interactions make us who we are. So look at space and time. Something you know about space and time. The universe is very old, very big. So that's a big idea of physical science. In order for us to understand physical science, we have to know that the universe is both very old and very big. Next, matter and change. A very small amount of the universe is matter. That's important. Most of it's empty space. All matter that you're familiar with is made up of the building blocks that we're going to study, which is called atoms. Forces in motion. Again, this is more physics-based. Forces like magnetism and gravity cause changes in motion. The laws of physics are going to allow these changes to be calculated. We can predict what's going to happen, and we can look at what happens in one situation and apply it to another situation. Energy, lastly, energy exists in many forms. Energy can be transferred from one form or actually from one object, but you can never destroy it. So those are four really important things going on, big ideas in physical science. Science is a process. It's a huge body of knowledge. We can add to it. We can use models. The big thing is, and you do this naturally, be skeptical. Ask questions. Be aware that what we have today could change tomorrow. It doesn't mean science is wrong. It just means that the knowledge is growing. The scientific process is pretty cool. So an example of technologies that is related to the science of physics, for example. Let's see. Which one would that be? Think about that. The answer, of course, would be a radio telescope. Physics is definitely going to help us understand a lot of things, and technology, the radio telescope will help us understand physics. Which of the following would not be included among the main ideas of physical science? Well, if we look at this here, physical science deals with a lot of things, but one thing it doesn't deal with is living systems and organisms. That's biology's job. And last but not least, natural science is divided into 3 overlapping branches: physical, earth and space, and life science. And as you look back at your notes, you know that, of course, is true.